Hi everyone, for this lesson I'll show you how to factor out special cases. First one we're going to look at is this example here. We have x squared plus 6x plus 9. Now we know we can factor this one out if you can write the first and the last terms as perfect squares. So in this case you can. The 9 can be written as a perfect square, which is just 3 squared. Same thing with the x squared. That can be written out as x squared. Now we have to think of the middle term here, the 6x. If we can find the product of x and 3, which is 3x, and if you double it, you get the 6x, which is the middle term, we can write this as the square of a binomial. So what that means is this. So we can make a set of parentheses, and we know that the x can go here and the 3 can go here, and since this is the plus sign, we'll put the plus sign in between the x and 3, and now we can write this as the square of this binomial. So this original trinomial can be written as the square of this binomial here, and you can check by foiling this binomial out to get the original x squared plus 6x plus 9. Okay? Alright, so now let's take a look at this one here. Right? Again, we can write this 36 as a perfect square, which is 6 squared. And we can also write the 4x squared as a perfect square, which is 2x in parentheses squared. Now, let's take the 2x and times it with the 6 and double it and see if it equals the 24x. And in this case it does, because 6 times the 2x gives you 12x, and if you double it you get the 24x. So now we can write this as the square of a binomial. So here is the set of parentheses. We know that the 2x will go here and the 6 will go here, separated by the plus sign, and we'll just square it. And again, you can FOIL this out to get the original trinomial, and it does, so it checks out. So this is the square of the binomial when we started off with this trinomial here, which is 4x squared plus 24x plus 36. Alright, here's another special case. We have x squared minus 25, and again we can write the 25 as a perfect square, which is just 5 squared, and the x squared can also be written as a perfect square, which is x squared. But notice there's no middle term, so in that case we know it's a set of two binomials where there's a plus and a minus sign, and the x and 5 will go here and here respectively, and the same with the other binomial, right? So this x squared minus 25 can be factored out into these two binomials. And again, you can FOIL this out to get the original. In this case, it's just the binomial. Okay, let's take a look at this last special case here, which is not obvious that you can pull out perfect squares from the polynomial. So what you want to do first is factor out a GCF. So in this case, between the 18 and 50, I can factor out the 2. So let's do that. So if I factor out a 2, what's left inside the brackets will be 9x squared minus 25. Now if you look at the polynomial inside the bracket, you can write perfect squares. So 25 you can write as 5 squared. And 9x squared can be written as 3x in parentheses squared. Okay, so now we can write these two perfect squares as the product of two binomials. So here's the brackets. Right? So now the 3x plus 5 will be one binomial, and the other one will be 3x minus 5. Right? Because we want the last term to be a negative 25. So it'll be plus 5 minus 5 here. Okay? And don't forget about the 2. So we got to bring that down. So we started off with 18x squared minus 50. We factor out the GCF, which is the 2. And what's left over was the 9x squared minus the 25. And then we rewrote that as perfect squares, which is the 3x squared. And then we have the 5 squared. And then we broke that down into 2 binomials, or the product of 2 binomials. One was the 3x plus 5, and the other one was the 3x minus 5. Right? So we went from here all the way down to here. So we factored out the 18x squared minus 50. And we're done, and we're happy.